Alright guys, today we are in Chapter 4. We are going to be doing an introduction to functions. This is 4.7, the Arithmetic Sequences. First off, our vocab sequences is an ordered list of numbers that often form a pattern. That's definitely a big takeaway here. Focus on the patterns. Term of a sequence is just going to be each number in a list. Arithmetic sequence is the difference between consecutive terms is constant, so they have a constant or a common difference between them. And recursive formula is a function rule that relates each term of a sequence after the first to the ones before it. So our main objectives here is we can identify and extend patterns in sequences, and that we will be able to represent arithmetic sequences using function notation. Our essential understanding is when you can identify a pattern in a sequence, you can use it to extend the sequence. You can also model some sequences with a function rule that you can use to find any term of the sequence. So we're going to go down to problem 1, extending the sequences. So we have to describe a pattern in the sequence to try and find out what the next two terms in each sequence is going to be. So letter A here. We start out with the first term in the sequence is 5, next term is 11, then 17, and 23. So the big thing that we notice right away is that these are actually increasing at a constant rate. So going from 5 to 11, we see that it's increasing by 6. Same thing with increasing from 11 to 17. It's going up by 6 and again to 23. So in this situation, our last term that we used was 23. If we were to continue by adding that constant rate, 23 plus 6 would be 29. And then if we were to add 6 again to 29, we would get 35. So those are going to be the next two terms that would occur in that sequence. Going down to letter B, first term we have 400, then 200, 100, and then 50. So a big takeaway that we notice right away is that these are halving as they go down. We're dividing by 2 every single time. So to keep up that pattern, we're going to have to divide 50 by 2. 50 divided by 2 is 25. Then we have to keep going with that constant rate and divide 25 by 2, and that'll give us 12.5. Letter C, this one's a little bit difficult. We've got some negatives in here, so we're jumping around. It's not just a steady pattern with like adding or subtracting a number. So first, we go from 2 to negative 4, then to 8, and then to a negative 16. So big takeaway on this one, to go from 2 to negative 4, we have to multiply by a negative 2. Same thing with negative 4 to a positive 8, and the positive 8 to a negative 16. So that means for our next number, we have to multiply a negative 16 times negative 2, which will give us a positive 32. And then the positive 32 times negative 2 is going to be negative 64. Alright, now I'm going to give you guys a second to try A and B in the next section. Okay. For the first one, we have negative 15, negative 11, negative 7, and negative 3. So to go from negative 15 to negative 11, we're adding 4. Same thing with negative 11 to negative 7, and so on to negative 3. So we do negative 3 plus 4, which is going to give us a positive 1, and then adding another 4 onto that would be positive 5. Letter B, we have 4, 6, 8, and 10. To go from 4 to 6, we could get that by adding 2. Same thing with 6 to 8, and so on 8 to 10. So for our next one, we have to add 10 plus 2, which is 12, and then 12 plus 2, which is 14. Okay, so problem 2. Identifying an arithmetic sequence. You have to tell whether the sequence is arithmetic. If it is, what is the common difference? So for A, sequence goes 8, 15, 22, and 30. Okay, well from 8 to 15 it increases by 7. 15 to 22 it also increases by 7. But we got a problem here. With 22, if we were to add 7 to that, that's 29. That's not 30. So that last one we're actually adding 8. So that would mean that this is not a sequence. So no. For letter B, we have 7, 9, 11, and 13. You guys might see this one pretty quickly, but it's going up by 2 every single time. So this one actually will be a sequence, and the common difference is going to be plus 2, or adding 2. For C, we have 10, 4, -2, and -8. To go from 10 to 4, we would subtract 6. 4 to -2, we also subtract 6, and -2 to -8. So for this one, all 3 of those had a common difference. So yes, it is a sequence, and we subtracted 6. All right, now this last one's a little weird. We're kind of bouncing around from 2, -2, back to 2, and then back to -2 again. So to go from 2 to -2, we would multiply that by a -1. To go from -2 to 2, we would also do another -1. And then same with the last one. We're still multiplying by a -1 for all 3 steps. So this one does not have a common difference.
How about our joke? Does our joke have a common difference? 1 cheesy tortilla, 1 cheesy tortilla, 2, 3, 5, 8. Does that have a common difference? No. It's just funny. Fibonaccios.
I was going to say, yeah. It was like Fibonacci sequence.
Mm-hmm. Fibonaccios.
All right, I'm sure you guys love that. All right, so you guys are going to try the next section. See if you can do A and B. All right, for A, we had 7, 11, 16, and 22. So to go from 7 to 11, we would add 4. 11 to 16, we're going to add 5. And 16 to 22, we're going to add 6. So there is a pattern, but not what we're looking for. They do not have a common difference. We would need all of those numbers to be the exact same. For B, we go 3 to 9, 15, and then 21. So to go from 3 to 9, we add 6. 9 to 15, we'd add 6 again. And then 15 to 21, we're doing it one more time. So yes, this one is a sequence, and the common difference, we are going to add 6. Okay, problem 3. We are going to write a recursive formula. For this, we're going to let n equal the term number in the sequence, where a of n is equal to the value of the nth term in the sequence. A of n is equal to a times the quantity n minus 1 plus the common difference. If we would say that a with a 1 in parentheses, that means that we're talking about the first term in the sequence.
And when we write these guys, only the common difference and the first term change in an arithmetic sequence in recursive form. Those are the only thing we're going to change each time. When we write it, a of n will be there, a of n plus 1 will be there, or n minus 1 will be there, a of 1 will be there. Common difference changes, the first term changes, and that is it.
Okay, so for this first one here, first we need to find out what the common difference is. So we go from 3 to 9 to 15 to 21. So we see that it's adding 6 every time we go to the next number in the sequence. So that means that our a of n is going to equal a times quantity n minus 1, and we're going to be adding 6. So for us to write the first term, our first term that we have in the sequence would be the positive 3 that we start with.
Okay. That right there is the recursive form. Both of those pieces together.
So pretty much with this, what we're really trying to summarize is, you know the starting point. That's going to be your A1. So you know that it's going to start at 3. And then if you were to plug that number into our equation that we have, you can continue on and figure out where all the next numbers are going. In this one, we see that they're increasing by 6.
So we were told we want to find which term. We want to find our 9th term. So our second term is going to be our first term plus 6, which is 9. Our third term is our second term, 9, plus 6, which is 15. Fourth term, 15 plus 6, which is 21. Those we were all given. Now we're going into the unknowns. Our fifth term is 21 plus 6, which is
27.
27.
So you keep going with that. So your sixth term would be 27 plus 6, which is going to be 33. Your seventh term would be 33 plus 6, which is 39. Your eighth term would be 39 plus 6, which is going to give you 45. And then your final term, your ninth term, is going to be 45 plus 6, which is 51. And that is the ninth term that we were looking for.
A lot of work to get there.
So for B here, we're going to do the exact same thing. First, we got to figure out what our constant rate of change is, what the common difference is. So going from from 23 to 35, we see that it's adding 12. From 35 to 47, adding 12, and so on. So from there, we can write our equation. We have that a of n is equal to a n minus 1 plus 12. That's really the only number that's going to be changing there at the end, is that plus 12. So our first term, they give us, we've got our a of 1 is going to be 23. So now we can continue on with the pattern, but let's actually just take it off from where they left. They gave us the first 4 terms. So we're going to go on and just try and find the fifth one. So our A5 is going to equal 59 plus 23, because that's our common difference, which is going to be 71. Oh, I'm sorry, plus 12. So yeah, I'm sorry, 59 plus 12, which is going to be 71. So our next term is going to be 71 plus 12, which is 83. 83 plus 12 is 95. 95 plus 12 is 107. And then our ninth term is going to be 107 plus 12, which is 119. That is our ninth term. So a little bit easier for you guys, don't have to write out all the work. And you can see the pattern that there is, just as long as you keep on following that and keep on adding or subtracting the common difference. So C is going into some decimals here though. So we start with 7.3 and we go on to 7.8. So we see that it's adding 0.5 or a half every time. So right there is going to be our common difference. So we can write out our equation now. We've got the a of n is equal to a times the quantity n minus 1 plus 0.5. So to continue on with the sequence that we have, last term that they ended on was 8.8. So for the fifth term, we'd have 8.8 plus 0.5, which is 9.3. Sixth term, we'd add another 0.5, which is going to be 9.8. Next term would be 10.3. Following is 10.8. And our last term would be 11.3, and that is the ninth term. And see, again, all we're doing is we're increasing by the common difference. We're just going up by 0.5 every single time. All right, so for the next two, you guys try, see if you can figure these out. Make sure that you find the common difference first, point out what the first term is, and then continue on in the sequence. So for the first one, we start with 97, and it goes to 88. So we see that they're subtracting 9 every time in the sequence. So for our equation, we can write a of n is equal to a times the quantity n minus 1 minus 9. And we know that the first term is 97. So we're going to leave off with the term that they left us off on, with the 70. So to find the next term, we would do 70 minus 9, which is going to be 61. Next would be 61 minus 9, which is 52. Subtracting another 9 is going to give us 43. Then 34. And 25 is our 9th term. Okay, for letter B, first term we get is 25, and they're going to 31. So we see that they're adding 6 every time in the sequence. So that is our common difference. So our equation is going to be the exact same, except at the end we're going to have a plus 6. The first term that they gave us was the 25. And we're going to continue on with the 43 that they had, and we're going to add 6 to that. So 43 plus 6 is 49. Plus another 6 is 55. 61. 67. And then 73 is our 9th term. Okay, for C, we're asking if a recursive formula, or is a recursive formula a useful way to find the value of an arithmetic sequence, and if you can explain that. Now, the way we're looking at this is it's only when the term is fairly close to the target. So for these, we have these sequences and we were given the first 4 and we were asking for the 9th. Now, if we were given a situation where they were asking for, say, the 25th number in that sequence, that would take you a pretty long time to figure out. So definitely the larger number of terms that you have would mean that you have a lot more steps to actually figure out the answer. Okay, on to problem 4. We're going to be writing an explicit formula. So for this, you definitely want to make sure that you're paying attention to what we talked about earlier. The things that change are the first term and the common difference. Your nth term and the term number, those are always going to remain the same. You're always going to have those same things in there. So for problem A, you were planning a trip to Chicago and plan to use the L to get around. You bought a Venture card with a starting value of $50. After one ride, there is $47.50 left. After 2 rides, it's $45, and after the 3rd ride, it's $42.50. Write an explicit formula to represent the value remaining on the card. What is the value after 15 rides? And the hint is the starting amount is the first term in the sequence. So, I think the first step that we should do on this is we should try and figure out the start of the sequence, because they give us 3 terms right away, or actually 4, I should say. So we've got the 50, 47.50, 45, and then 42.50. So we see that between each one of those sequences, our common difference is $2.50. That's what we're decreasing by every single time. So now to try and write our equation up here. So definitely follow the example above if you guys have to. So you have your a of n is equal to whatever our first term is, which is 50, plus our n minus 1. And then our last part is going to be the common difference. And we are subtracting by $2.50 every time, or 2.5. Make sure you keep that negative though. You don't want to be adding any money to that. So the thing here though is that they're asking what is the value after 15 rides. Now one part that might be a little bit tricky is you might think that you need to plug in the value 15 for this. but it's after 15 rides. So technically, that would be the 16th time that you're going to be riding it.
Well, it's the 16th term in the sequence.
Oh, yes.
Because the first term is your starting value.
That's a much better way to put it. So now we're going to plug in the 16 for n and solve this just like we would any other equation. So we're gonna 50 is going to remain the same. 16 minus 1 is going to be 15. And then we need to multiply that by the negative 2.5 that we have for each ride. So 15 times negative 2.5, that's 37.5. So we have our $50 that we started with minus $37.50, and we are left with $12.50. So B is actually asking us how many rides can be taken with the $50 pass total.
So we can start off with our original equation. And we want to know how many rides can be taken with this pass. Well, that would take the pass all the way down to $0. All right. My first step, I'm going to subtract 50 from both sides. So I have negative 50 is equal to n plus the quantity n plus 1 times negative 2.5. Divide both sides by negative 2.5. Sorry, n minus 1. So negative 50 divided by negative 2.5 is going to be 20.
Is that 20?
Add 1 to both sides. So after the 21st term, our pass will be used up. But that 21st term is the 20th ride. Because remember, the first term was our starting value. So you could get 20 rides out of that one $50 pass.
Okay. So you guys try A. We'll see what happens there. Okay, so on Olivia's first birthday, I put $100 in a savings account for her. I plan to put $125, $150, and $175 in on her next 3 birthdays. If this pattern continues, how much will I put in on her 13th birthday? First off, that's a lot of money. I just want to say that.
Mm-hmm.
So they give us the first few amounts in a sequence. We've got the 100, 125, 150, and 175. So we see that the amount is increasing by $25 every time. So that is going to be our common difference. It's going to be going up 25. So for this, next step we got to have is what number are we going to plug in for n? Well, the ask is on here how much they will put in on her 13th birthday. So that is going to be our n value. So then we'd have our 100 plus 12, well, eventually. Plus 12, and then times the $25 increase. So make sure you follow order of operations here. You're going to be multiplying the 25 and the 12 first. And that will get you $300. And then $100 plus the 300 means that on the 13th birthday, he is going to add in $400 to her account. Okay, if you guys can just let us know your level of understanding, just working through the lesson. Let us know how you're doing, if you think that you could teach this, or if we did not explain this in a clear way and are completely lost. Thanks again, guys.